You guys are so lucky because you're getting this course from me. Everybody else, every other computer science person on earth will tell you dynamic scope is just a mistake. Lexical scope is the right thing. And the reason they all say that is that they're envisioning industrial computer programming. Right? We have a lot of people working on a computer program, and it has to work every time. It's got to be bug-free, and it has to be fast, because it's going to be used over and over and over again. Right? In education, the program isn't going to be used over and over and over again. As soon as it works, you go on to the next exercise. Right? It doesn't matter that much if it's fast, as long as it's not excruciatingly slow. And so the values are different. And so if you're writing a language for kids, I claim, you want it dynamically scoped. Parenthesis, BYOB isn't. It's lexically scoped. And later on, people who are BYOB fans, we can talk about why that is. But I don't want to confuse things right now. Smalltalk is dynamically scoped. Alan Kay's language for kids. OK, lexical scope is good because, as you know, if you have lexical scope and you also have lambda, then you get free object-oriented programming, right? Because you can have local state variables by putting a lambda inside a let, right? Or in other words, a lambda inside a lambda, basically. And lexical scope plus lambda gives you that. Now, most lexically scoped languages don't have lambda, although that's starting to change. I think for people my age, this is really very amusing. It's one of those amusing things. 50 years ago, 60 years ago, when Lisp was invented, everybody immediately started making fun of it. 50 years later, everybody's still making fun of Lisp. But now, their favorite language also has lambda. Right? So it's like we're losing the battle of what the language should be called, but we're winning the battle of how it should work. Anyway, so lexical scope allows local state variables. Dynamic scope allows first-class expressions. OK, so the example I just showed you with map. Depends on dynamic scope. Because it means that an expression is as good as a procedure would be given dynamic scope. Whereas in scheme, quote times xx is a very different thing from lambda of x times xx. But in Logo, they're not so different. OK, lexical scope prevents name capture bugs. What does that mean? Suppose I say, kind of a silly example, define, no, not scheme, Logo. Make, quote, pi. Make is a combination of define and set bang. It just set the variable to this value. If it didn't exist, make a global one. It's not a special form, so I have to quote the variable name. 3.141592654. OK, now I say to pumpkin.py print, I don't know, area 5. 2, area dots radius output, abbreviation for output, dots pi times dots radius times dots radius end. Okay? So now if I say print area 5, that's 25 times pi, basically. 25 times 3 would be 75. It's a little more than that. Okay? Now if I say, wait. Now if I say pumpkin 4 the area of a circle of radius 5 has become 100. Right? Not out here. Print area 5. This still works. But because pumpkin happens to have pi as a formal parameter, this procedure area, which thinks it's using the global variable pi, is actually using this local pi. That's called name capture. Pumpkin is capturing the name pi that area expected to mean something else. Okay, so that's a source of bugs in dynamically scoped languages. And it's true it is, although sometimes it's a behavior that you want. Remember the time that the legislature of wherever that was almost did declare pi equal to 4? You know that story? Some idiot state legislator decided that arithmetic was too complicated with pi having this screwy value. And it would be so much easier to do engineering computations if pi were 4. So he introduced a bill declaring pi to be 4. And luckily, some statistician from the university of whatever state it was happened to be visiting the legislature that day about a completely different issue and, you know, hit the roof and didn't let them pass the law. Anyway, so name capture bugs. On the other hand, it lets you have what I'm calling semi-global variables. What I mean by that is I'm a kid, I want to draw a picture, and the picture has a house and, you know, a door and a window and whatever, and there's a path leading up to the house, and there's a nice fractal tree next to the driveway, and there's a car on the street, and all of that stuff, okay? And now I'd like to be able to do this in different sizes. So I'm going to have a procedure to picture dots size. And then it's going to say house, road, tree, car, end. Okay? Typical kid procedure. In house, I'm going to say to house. And then I can say, you know, forward dot size, etc. Move that many steps. If I wanted to do this in scheme, all of these procedures would have to take size as an argument, right? In Logo, I don't have to do that. That's what I mean by a semi-global variable, and it's just sometimes very convenient. And kids, you know, understand it perfectly well. Finally, good thing it's finally, because we have 1 minute left. A lexically scoped language makes for faster compiled code because the compiler knows which variable, which binding is meant by any variable name reference without running the program. Because the variable name refers to a variable of this procedure, if there is one like that. Otherwise, the enclosing procedure in the definition, otherwise the enclosing procedure of that out to the front. So the compiled program doesn't have any variable names in it at all. It says something like, look at the third slot in the fourth frame back from this one. And that's just a few machine instructions to jump around to there. A dynamically scoped language, the same variable reference can mean two different variables, as we saw about this variable reference, depending on the context in which the procedure is called. So you have to look up the names at runtime, and that slows things down. On the other hand, if something goes wrong, and your program has an error, I don't have time to actually show you this, but you can have the program stop at the point of the error, give you a logo prompt, but in the environment where the error happened. And because of dynamic scope, you can see the variables of the procedure where the error was found, the variables of the procedure that called it, the variables of the procedure that called that, because the actual mistake in your program, I'm sure you've had this happen, the bug in your program might be in a different procedure from the one that actually had some primitive blow up, right? Maybe your procedure A called procedure B with an invalid value, and B called C, and C called some primitive that blew up, right? So in order to find the bug, you have to look at the variables of procedure A, and with dynamic scope, you can. It's just there. Lexically scoped languages have to give you this complicated interactive development environment thing where you use mechanisms outside of the language to look around the environment.